The one and only multiverse presents a grand unified theory. William Gilbert, 1544–1603, age 59. James C. Maxwell, 1831–1879, age 48. Silicon, iron, cobalt, copper. Pole magnetism, metallic magnetism, magnetic spatial force, torus fields and ring fields. Web page and video is not AI generated. Your host, Richard E. Noer. Magnetism, a physical dark matter spatial force produced by spinning material movement. No spin, no magnetism. It has measurable height, width and depth and is polarized. It also can be metallic or non-metallic, quantum fields determine that. And last, magnetism is the only physical process that can be compressed, expand and store energy. XCP dark energy. B. There are two spatial forces created by matter. First is the basic non-polarized space, with its own weak moving bits of matter. This primal space is at the cold outermost expanse of the cosmos. It has lost all its polar axis spin and flow, therefore only produces a tiny separating spatial force. This is because its matter can only move, vibrate, and bounce around, thus creating a small fluid height, width and depth of movement. C. The next spatial force is polarized. Pole magnetism. This is produced by primal matter that has been molded into a spherical form, and forced to spin. This in turn creates pole magnetism, with a one-way spatial flow through the matter's spinning axis. This polar magnetism has the ability to expand, contract and push and pull as the matter's movement changes. A dark energy force. D. Polarized magnetism is not only produced by a black star supernova, but also by creating spinning particles out of primal space. This happens when primal space, with its weak but vast spatial existence, comes in contact with the black star. The gravity of the superstar gets neutralized and it goes supernova. This starts a super-fast chain reaction of particle release of the superstar, which in turn drags in primal space, and converts it into tiny, compressed spinning spheres. Both the black star spheres and the ones created, in turn, is what creates the new pristine oceans of a dark matter sea, which is the basic medium of the multiverse. TM calls these tiny spinning spheres, universal dark matter particles, UDMPs. They are the basic building blocks of everything we know. D. Now take a deep breath, for what you are about to hear contradicts a lot of people and their life's work, but it has to be said. E. Conclusion: matter plus magnetism equals existence. Void, or the vast expanse of empty space, does not exist. Polarized space. Dark matter space. Dark matter particles create a polarized spatial force. Spinning gyroscopes also create a spatial magnetic force. Polarized magnetic force of the dark matter sea. Polarized space. A pulling, pushing, expanding, and compacting medium. TM theory: magnetism is not exclusively metallic, proprietary quantum fields determine that. Magnetism is the energy that creates changing space between particles and bodies of matter. Universal particles that make up dark matter space are spherical and spinning. This creates magnetism and a north and south pole flow for each particle. Faster spin in the opposite direction between particle poles create a strong repelling force. Slowing spin a weaker force. If the particles are rotating in the same direction, pole to pole to pole, it creates an attracting force between poles, which in turn creates strings of particles. Faster, slower movement of the spin energy changes the amount of force. The particles never actually touch because of the spin and plane orientation of adjacent particles. The force between particles is polar magnetic and can vary the space and strength. The attracting-repelling force doesn't only create gravity, anti-gravity, it creates the changing density mass index of the universal particle medium. DMI. When universal particles attract and align end to end like a strand of pearls, their rotations synchronize in one direction. This is called a magnetic string. Remember that all particle rotation influences adjoining particles. Rotational strings set up counter-rotational strings. This keeps the strands ever so slightly separated. Because of the string's tiny size and their minimal strength, they continue to form many strings next to, and, in line with each other. These strings can extend, and create twine, and twine can form rope-size fields and become stronger. Now, because so many particles are involved, it is easy for the magnetic chains to bend and loop. When yarn-size fields loop around themselves and meet end to end, they will bond in what is called a closed magnetic loop. The spin direction of the interlaced magnetic fields will determine what kind of protostructure has evolved. Spinning CW bonded yarn-size fields is what creates a proton. The fields loop through a center axis and physically close the structure. These CW fields also have spinning CCW companion fields, but they are squeezed out and prevented from going through the axis. The newly created body has super strong magnetism and is a horn-torus configuration. Proton. The strong nuclear force, the multiverse has re-evaluated the standard model, and there is new thinking about this. The strong nuclear force is not the force that bonds the proton and neutron together. It is the magnetic lock of the closed looping fields of the proton, neutron, electron, and neutrino. These fields are super strong and their magnetic force is set at the moment of closure, relative to the surrounding dark matter medium. They don't add or shed more dark matter particles, but, if some fields in the structure are not closed, the body can add or shed particles. This happens with a proton and electron. They both have open loops in between the closed ones. The neutron and neutrinos loops are all closed, so there will be no increase or decrease of dark matter particles to their structures. B. There is one other instance of the strong force. This is the magnetic chains of a black star. These bonded fields are so strong they overwhelm gravity. This is because the power of bonded spinning fields have much more energy than the movement of expansion or contraction. So the strong force is not the force that sticks the protons and neutrons together, that is actually the weak force. The strong force is really the glue that keeps the structures of the protons, neutrons, and electrons intact. The weak nuclear force, the weak force is the open-ended CCW strings of the proton. They are capable of bonding with CCW closed looping strings of the neutron, if they get close enough. The bonding is not a physical joining, but is a weaker magnetic attachment. If there is sufficient external gravity, or spin wobbling or rogue collisions, the linked magnetic CCW fields of one or more protons and neutrons will fail, and radiation of joined free radicals will occur. This causes lighter configurations of proton-neutron nuclei to take place. As you can see, the non-looping fields of the proton are very important and give the proton its positive charge, but if fission or decay of the atom occurs, some of the nucleus proton CCW fields can be pulled out. When this happens, the different proton-neutron pairings that are intact will rebuild, and new quantum fields will reform. In any case, free radicals occur when both the proton and neutron sticking force separates. B. Lastly, the magnetic strength and its interaction with particles and bodies can be complicated. TM says, magnetic force is not just about strong and weak, it has an infinite amount of degrees. This is because of gravity, anti-gravity, closed loops, open loops and black stars, they all have their own magnetic forces. Quantum torus and ring fields. Top view. Hydrogen with ring fields and no electron. Top view. Hydrogen and ring fields with an electron. Torus proton with stacked quantum ring fields. When a proton is created in the multiverse, because of dark matter there is no emptiness around it. If the proton has little or no lateral movement but has lots of spin energy, the universal particles that surround the proton will develop currents. The dark matter medium surrounding the proton now has become rich in spin and magnetic flow energy. The energy of these fields has become what is known as quantum fields. Now it gets interesting. There are two types of quantum fields, ring and torus. Ring fields form in multiple horizontal planes perpendicular to the rotation axis of the spinning proton. Torus fields form at the poles and can create looping, interactive, one-way magnetic flow strings. Axis-to-axis chains. So, quantum fields have two flavors, ring and torus. Not only can quantum ring and torus fields surround the proton, but on a much larger scale, they surround the atomic nucleus of an atom, The first ring field, that's around an atomic nuclear core, is a super strong horizontal containment field. The next field out in the same plane, not so strong, and so forth, and so on. The neutron doesn't create strong quantum ring fields because it has a neutral charge, and low if any, external spin energy. Finally, the proton has a unique proprietary quantum ring configuration, and so do atoms. The number of protons and neutrons in the spinning core of atoms and its vibrating magnetic energy, is what creates a blueprint for quantum ring field construction. Strength, intervals, and compression of the fields are directly linked to the nucleus of core composition, its magnetism and spin energy level. Extended magnetic strings. Torus string fields in dark matter space. Metallic quantum torus fields. A. Same magnetic pole to pole, opposite spin and flow energy of quantum strings repel. B. Opposite magnetic pole to pole, same spin and flow energy of quantum strings attract. Metallic quantum fields graphic. If you think this is a bar magnet with magnetic fields, you are right, but these fields are also called metallic quantum torus fields. This means they have unique structures with a strong stepping force and intervals. They are so strong they radiate from their linked iron atoms for quite a distance in surrounding space. These quantum fields are in a locked magnetic state and do not have associated electrons, only ring fields do. This is because electrons can't orbit in torus string fields, they are repelled. Only ring fields have orbiting electrons. The two-bar magnet attraction, repelling riddle, question, why, if you move two magnetized iron bars close together, but not physically touching, north pole to north pole, or south pole to south pole, they physically repel each other, and when you move the opposite poles close, they attract? Also, all the bar's surface is attracted to non-magnetized iron. What is going on? How does this happen? This question is at the heart of all physics and has never been adequately explained. This is because the standard model of the universe is flawed, and has no idea how magnetic quantum fields are produced and react to different forces. Only the multiverse has the correct answer. The attraction-repelling force is produced because the nucleus of all the iron atoms are spinning. This creates quantum ring and torus magnetic fields inside the bar. If the spinning atomic nuclei of magnetic iron, and their ring fields are linked, with their poles in the same direction, their quantum torus fields will gather together and complement each other and make magnetic strings that can extend outside the bar into space. B. Now, because the spinning cores in the bar are aligned, they produce a north and south pole magnetic flow for the whole bar structure. These iron quantum torus fields of both magnets have the same spacing, quantum stepping intervals, therefore will interact. See, now for a big reveal. It is the spin and flow energy of the multi-stranded chain torus fields inside the bar, that creates a north to south pole attraction outside the bar. This is because the bar is held together by linked ring fields, but the communal looping of the torus fields in the bar can't spread out. The branching and widening of the chains happens outside the bar, where iron atoms are not hard linked. D. Hold on to your magnet. It is the flow and looping rotation direction of the bar's outer torus fields that attracts and repels. That's right, the outer torus fields of the bar not only have spin energy, they also have magnetic flow direction, and loop around to the other bar pole. This is because they are less influenced by bonded ring fields inside the bar. The direction of the quantum torus flow is dependent on pole orientation of one iron bar to the other. Only when the flow energy is in the same direction of both bars, can they join, attract and couple. When this happens, the outer torus fields intertwine with inner torus fields, and the two bar magnets now become one. The bar now has two external poles, north and south, but only one flow direction inside the bar. It is the outer torus fields only, that can loop around. When torus string fields get very close together, compact, intertwine, it significantly increases the magnetic pulling power. This is because the universal particles' pulling strength inside the bar are physically smaller and much stronger. This means, outside approaching torus fields, have increasing density, with an increasing pulling force as they get closer together. North to south pole or south pole to north pole. That's why magnets are so strong and get stronger the closer they get. This magnetic force will override the weaker gravitational force. There is one exception, the gravity of a black star. Okay, that's nice, but here is a big question. How come iron can have no magnetism and then become magnetized? Aha, that is a great question. If the spinning nucleus of all iron atoms are haphazardly oriented, but the ring fields are still physically coupled, there will be little or no communal torus fields. This means that iron atoms' ring fields can link together even when some of the atoms are upside down. Now if you apply an electric current to the atoms that are randomly linked, the spinning nucleus of each atom will switch orientation in response to the electric current. This aligns all the iron nuclei north and south poles, which in turn creates complementing radiating torus strings for each atom. If the electric current is strong enough, the linked iron atoms can remember the orientation of their spinning nucleus, and retain the configuration. This now magnetizes the iron bar. B. On the other hand, if the iron bar loses the electric current, the spinning nuclei may change back to their original orientation, along with the torus fields. That is, if the iron bar hasn't become permanently magnetized. Attraction, repulsion for universal particles and magnets. Torus fields spin and flow. A. End arrows indicate spin direction, center arrow indicates flow direction. Notice both magnets are identical. B. North pole to north pole repels, and opposite spin direction repels. Flow direction is opposite in both magnets. C. South pole to south pole repels, and opposite spin direction repels. Flow direction is opposite in both magnets. D. North pole to south pole attracts, and same spin direction attracts. Flow direction is the same for both magnets. E. South pole to north pole attracts, and same spin direction attracts. Flow direction is the same for both magnets. Spinning universal particles create a north and south pole for each, but this is misleading. It is only partially correct when you say opposites attract, and same direction repels. This is because relative spin energy is not the same when you flip one particle upside down in relation to other particles. It is the spin energy of the universal particles in a one-way polarized force that creates the same and opposite magnetic repelling, attracting ability. So, we do use the north to north pole repelling metaphor to explain the attraction repelling force, but with a caveat. Be aware that orientation can change, but the name and flow remains the same. This may be confusing to some people because of relative opposites and physical opposites. This dilemma could be solved by using high and low pressure streaming forces to explain spin and flow, but who wants to rewrite the dictionary? Besides, this may be even more confusing to some people. So, same spin and opposite spin direction of particle to particle does attract and repel other particles. Same spin attracts, opposite spin repels, but pole to pole magnetic flow has a different orientation. N to N repels, S to S repels, N to S attracts, S to N attracts. Still confused? Separate the spin energy from the magnetic flow between poles. Only magnetism can be compressed and have potential energy. When you force two same pole magnets close together but stop them from touching, you have created a potential repelling force of magnetism. When you let go, the poles push apart. Only magnetism can be compressed with XCP dark energy. For magnetic lines of flux, see the Encyclopedia 5 segment, Earth's Magnetic Fields. Your host, Richard E. Noer. Young me mini me. Email, noerastronomy@gmail.com. Here in a multiverse, our goal is to find the cosmic truth. No matter where, or how far it takes you, the universe truly does unify. If you get the basics right,